Sweet! Welcome to today's lesson about solving simple exponential equations 1. It looks like this. If you don't have this assignment, you should pull it up either on Canvas or look at your paper copy. But before you dive into it, you need to know a couple things. So remember last time we were talking about exponent properties and you got things like if you have 3 to the negative second power, that means 1 over 3 squared, things like that. Those are going to come into play a little bit in what we're doing today, specifically this thing, this negative exponent property. But yeah, in order to solve exponential equations, you need to know a couple things. Namely, that if your bases are the same in your equation, on both sides of the equals, and that's the only thing there, then that's going to let you know that these exponents have to be the same. Meaning, if you want actual numbers in there, if you have 5 to the x power, and the other side is 5 to the negative 6 power, then that lets you know that whatever x is, it's got to be the same as this one because these bases are the same. So if the bases are the same, then the exponents have to be the same. And so really, if you get your exponents to be the same, you can just drop them and just put an equal sign up here, and you know that x is negative 6. And so that's what you're going to do. That's the end goal of every problem, is to try and make it look like this, and then you get rid of the bases, and you know what your x equals. So that's like the lesson. And so we're going to just do a few examples where we use that property to solve the equation. Remember, to solve is to find out what is the value for x. So let's look at number 1. Right now, our left side says 5 to the x power, right? It's ready to go. You just need to figure out what the other side is. The right side does not say 5 to something, but you can change it so it does look like that. And that's kind of where the most of the work comes in on today's assignment, is trying to get one of the sides to look like the other. So, right side. Well, we already know that we want it to say 5 to some power. And so really you can kind of just take a calculator and figure out what power do you put on 5 to get 125. And so you can play things like 5 to the first, 5 to the second, 5 to the third, and just kind of go through until you find the one that works. Or if you're not into guessing and checking, which that will definitely work, you can just take 125 and just divide by 5 and write down what you get. If you do 125 divided by 5, you get 25. And if you take that and you divide it by 5, you end up with 5. So this is called a factoring tree. You might have done it before. But you just take this, you draw 2 little lines that represent these 2 things times together and make this thing up here. And we just keep factoring as we go down. And now we've reached all 5s. You count how many 5s are at the end of all these branches, and that's the power that you put on 5 to make 125. There are 3 of them, and so 125 is equal to 5 to the third. And so I'm going to rewrite this equation, but replace the right side with 5 to the third. So my equation, just coming straight down here, is going to be 5 to the x equals 5 to the third power. And now that we have our bases the same, you can just drop them, and we know that x is 3. Hooray! On your actual paper, you probably shouldn't just like scribble out the 5s. You can just write out x is 3, though. Don't mind me, I'm just coughing a lot because I'm sick. All right. And that's the basic idea. That's what's going on your assignment. You just go to a problem, try and get both sides to say 5 to a power or 3 to a power, and then you can drop the bases and you just set the exponents equal and you're good to go. Let's try another one. Let's go to actually let's go to something like 4 real quick. Pause the video, see if you can get 4 figured out, and then come back and push play again. Right. 81 is, if you divide by 3, you get 27, you divide by 3, you get 9, divide by 3, you get 3. So it takes 4 3s to make 81. So the left side is 3 to the 4th power, and the right side is 3 to the x. And now we have the bases the same, and so x is 4. Hooray, we solved it. Nice. So if you got that, congratulations. If you didn't, you might have messed up the exponent part here. You just need to figure out what power to put on 3 to make 81. Let's try one that's a little bit more challenging. Let's look at 3. Left side here, we got 2 to the power, and on the right side, we have a scary fraction. Well, don't worry. Try not to panic. Step 1 of solving stuff is don't panic. You just need to remember that you get fractions because of a negative exponent. Remember, if you have something 2 to a negative 5 or whatever, you'd get 1 over 2 to the 5th. Or it could have been 4 or 3 or something like that. Whatever that power is. And so that's where this comes from. It comes from a negative exponent. And so if you're trying to figure out what exponent it is, you just need to pretend it's not a fraction for a bit. Pretend it's just 16. And figure out what power do you put on 2 to get 16. Well, if you divide by 2, you get 8. And if you divide by 2, you get 4. And if you divide by 2, you get 2. Awesome. So we got 4 2's times together make 16. Well, that means we can rewrite 1 over 16 as 2. Sorry, let me write this. This is 2 to the negative 4th power. Because remember, 16 is 2 to the 4th. So if you want the whole fraction, you just put a negative power on it, and you're good to go. And so the right side is 2 to the negative 4th power, and the left side is 2 to the x power. Now we have bases that are the same. They are both 2, and so we can drop them, and we got x is negative 4. Hooray! Answer! Sweet. So we're making some progress here. Making a lot of progress, actually. We're only going to do one more example. We're going to do one on the back as your final example. And this one has an extra thing in it. You may notice this has 1 term, and this has 2 terms. You don't want 2 terms. You want only 1 term. And so you have to get rid of this plus 2 thing. You can do that just by subtracting 2. So now we got 6 to the x on the right, and on the left side we got 2, 16. And now you have to figure out what power you put on 6 to get 216. Pause the video, see if you can figure it out, and we'll get back in a second. What'd you get? Did you get 3? Because I think it's 3. Here, 216 divided by 6 is a thing. Oh no, I don't have my calculator handy. No, I found one. Okay, let's see. 216 divided by 6. Yes, 36. Okay. And you divide that by 6, you get 6. Awesome. So the left side can be written as 6 to the 3rd power. So I'm going to rewrite left side, 6 to the 3rd. Now my bases are the same. I'm actually going to drag this down so it's a little bit less confusing. Less jumbled there. And now the bases are the same, so you can drop them. And you got that 3 is x, or x is 3. Problem solved. If you put a 3 in there, this equation would be true. So there you go. There's your lesson for solving simple exponentials 1.